So today we have another tool for you. We're going to talk about PROV, and actually we did talk about PROV one time before, but this time we're going to go a little bit deeper into some of its features, some of its benefits, things that it measures, and we're going to have Owen and Anmol both talk about PROV today. So we're going to have Owen to start us off. Sorry, Owen. There you go. Take it away.
Yeah, so like Carl said, we've done a video before on PROV, which discussed the general idea of PROV, what it's useful for, the software compatibilities, and some of the certifications it can help pass. So today we're going to be talking a bit more about the details on the timing measurements it can record and some more details on other relevant features. So first things first, we should discuss what is timing and why is it relevant. So imagine we're developing a system for a car, and many functions need to execute in a certain sequence to make the car do something. So each of these functions, even if they're logically correct, they need to do it in a certain amount of time. Otherwise, the outcome won't be correct. So for example, when a sensor detects an object, then it will signal that braking is required and determine the braking force that's needed. And then that braking force needs to be applied, and then the goal is to stop before hitting the object. So if each part of the sequence doesn't happen in the correct time, then you're going to hit the object. So there's instrumented tracing, which records the various timing measurements to see the task and interrupt execution, which helps resolve these issues, like figuring out which process from that example took too long. So in addition to that, all these measurements can be exported to a report that can be used for timing analysis beyond a statistical level. So checking which tasks are and are not meeting the requirements. And we can use all this data on the execution time collected to fix the problems and improve the design of the system. And these reports can be customized, and there's also default formats as well. So now I'll let Amol discuss some of the details about the timing measurements that PROV can make.
Thank you, Owen. So now, as Owen said, I'll go into some of the details on what types of times can be recorded while profiling. So we can split them up into two categories relevant to CPU and memory. For the CPU measurements, it has every element of timing that's recorded in AUTOSAR: execution time, response time, deadline, the period, slack time, preemption time, and the net slack time. In addition to this, it'll record all the task states, which is relevant for timing analysis because you can see what a task is doing at a given time, if it's running or if it's paused. And in addition to that, for the CPU itself, it can show the CPU load per core. So the whole purpose of this is meeting timing requirements. The difficulty in that can be the resources that you have available. Usually when you're in a resource-constrained environment, meeting timing can be difficult. So looking at the load of each core of the CPU can be helpful for optimizing which tasks are going to be run on which cores in order to help meet timing requirements. And now for the memory usage, it shows the maximum memory usage, again, for each task and interrupt and OS process. It can show the usage in bytes, the percent of stack size that is, and the percent of usage for each task. And this is for each core. So all the tasks on each core and those details for them. So those are all the measurements that it makes. What this helps in doing is the main thing, timing analysis. By running the code and then recording all these details, you can see distribution of the execution time. So maybe most times it runs in X amount of time, but 10% of the time it runs in whatever X plus 10. What's more worrisome for the team is the X plus 10 case, because if it works most of the time, that's not sufficient. Like in the example that Owen said, you can't miss the object just sometimes. All this information also helps, it does help this timing analysis to a considerable degree, because doing it otherwise can be very difficult. Without having such as the visuals that we mentioned. Fit also generates a scheduling graph. We sort of explained last time. Some of the bugs that can result in embedded systems could be a deadline miss in a task that's deeply nested, which causes, like visually, something else to go wrong. So your first intuition would be that, oh, maybe this logic is incorrect, maybe this logic is incorrect. But even if all that logic is incorrect, it would be very difficult to find out, oh, this is happening because some deeply nested function missed its deadline by 2 microseconds. So seeing those graphs and seeing the times can help you debug those issues. The last thing it can do in terms of helping with timing analysis is you can set triggers on variables itself. So if a variable exceeds a certain amount, so it's similar to fit as well, it's a similar feature. So you have control of if variables exceed a certain amount, it should flag that. In addition to the times that it will flag all deadline misses. So that would be all part of the first level and the second level you would conduct in timing analysis. And the last step, as Owen mentioned, you can take all these details and export them to a report and take them back to your requirements, compare, okay, so is this task meeting the requirements for it, and go through that and see if the product is all good. So again, we're going into a significant amount of detail, but in summary, we measure every timing element that is mentioned in AUTOSAR for each task and interrupt, in addition to the memory usage as a percent of stack size and a percent of usage for all available memory. All these details help to make timing analysis easier and find very tricky to debug issues that often arise in embedded programming.
I'm always super impressed by what you both present in these videos, because it's not only super detailed, but it's very clear as to how the tool helps and what it actually does and the benefits. So I hope that people get something out of these. And if you do have any questions, please feel free to let us know. We're more than happy to answer any questions. And we also offer a free trial of our tools as well. So please get in touch with us if you have any questions, and also if you want a free trial. Thanks for watching, and we'll talk to you guys next time. Bye for now.